So good evening, good morning, good night, whatever the time is there. So today we are going to talk about how agentic AI is revolutionizing healthcare sector as well for different processes, how we can automate some of the workflows. And I will be also walking you through to build these kind of workflows, how we can leverage Google's latest AI technologies. So before we start, just a bit about me. I work as a lead engineer at Matco, and I'm one of the Google developer expert specializing in AI and machine learning. And if you want to connect with me on any of the social media channels, Tech with Shadab is like my username across the platform. And I've been working extensively with Google's AI technologies and have seen firsthand like how this platform and whatever services have been getting launched have transforming real world are solving real world problems in different sectors. So this is about today's agenda. It is structured into five key areas. First, we'll start with the fundamentals of AI agents. I mean, many of you would be already knowing AI agents because of the industry hype, whatever is happening. But for those at least who are new, we'll try to cover up like a bit of fundamental. Then we'll start with what they are, how they differ from traditional AI models. And then after that, we'll start exploring agentic ecosystem and capabilities on Google Cloud Platform. And after that, we'll dive deep into the agentic AI concepts. And then we will pick up this medical pre-authorization use case where we will see how we can have a sample workflow to solve some of the administrative tasks over there. So this journey will take you from the theory to the practical implementation part. So before I start, those who know sort of like agentic AI or have developed production ready and have developed like production ready agentic AI workflows wherever you're working, can you give me a thumbs up? Like just as a reaction in the chat, just to know like what kind of background people are having over here. Awesome. A lot of people have already been working on agentic AI. Nice. It's really great to see you guys are already working and leading these kind of automated workflows. People who are new to sort of agentic AI, or if you don't know, you can give the thumbs down so that we know okay, Roy, Vivek, a couple of people are like, Sundari. Okay, nice, awesome. Good to see the just the overview of what background we all are coming from. So don't worry, like if you even if you don't know, we will be sort of covering up at least up to certain extent where after the session you should be able to build your own agents. So let's start with the fundamentals first to understand where we are going with agentic AI. And for that, we first need to understand the evolution of AI systems and why agents represent such a significant advancement in how we interact and develop AI, right? So starting with that, in the early days of large language models, if you remember when BERT and many other models, PaLM, these kind of natural language models were getting trained and released by all the big tech companies like Google, OpenAI, and all. So when a user, it was very simple interaction pattern in that at that time, right? Like if you go back 2021, 2022, or before, even before that, when we had very large, just language models, nothing else. So if a user is asking a question what is a Pixel tablet, or what is a Samsung tablet, something like that, and the model would respond based solely on its training data. We had a very clear limitation at that time. No external knowledge was exposed to the model, because of which we had outdated information because we were just able to get the answers based on whatever data has been used to train the model. And frequently the model used to get hallucinated. The model was working in an isolation environment, which was and which was limited by the training data at that time. After that, we started seeing the RAG. RAG was a game changer when this was introduced in the industry. Now, the same question when we were asking about the Pixel tablet could be answered with sort of current and accurate information by querying external knowledge as well, right? And so we were creating vector databases and all, which was giving access to the latest information, and it was able to significantly reduce hallucination. The model was no longer isolated of like when RAG was like emerged. And then the current era where we are moving is like the evolution of AI agents. So RAG was just the beginning, and AI agents sort of like they represent the next evolution system that can reason, plan, orchestrate complex workflows. And as you can see in this diagram, agents don't just retrieve information. They can use multiple tools, maintain state. They can make their own decisions about which tools to use, when, and or like which tools to use and when, and orchestrate the entire workflows, like based on the understanding or context or the planning it will be doing behind the scene, right? So this is the foundation of what we call agentic AI. Like instead of like predefining the systems and tools and the information sources and all, we are defining the whole workflows where we have the orchestration agent, we have the planning agents, we have the execution agents, we have the set of tools which are exposed to the agents, which take care of the end-to-end like workflows. So what is an AI agent, right? So think of it as an application that sort of like combines generative model capabilities with tools to connect to the external world, right? And it has a very high level reasoning to achieve a desired like end goal or state, whatever we like want it to perform. So AI agents are like not just about answering questions, it's about taking action, using tools, maintaining context, and working toward specific objectives. And if we deep dive a bit like into the architecture of like agents, how they look like, so it has like its own orchestration capabilities. So think of this as a brain that decides like what to do next. It will have access to sort of like multiple generative AI models, a rich set of tools, including APIs, functions, databases, and like even other agents. And it maintains both short-term and long-term memory. And it has like model-based reasoning and planning capabilities, which allows it to break down like any of the complex problems, and it can reflect on its own actions. So no more sort of like we have to give step-by-step instruction, do this, do that, and like plan out the whole like workflow, like what do we want to do. Instead, we can design the agent in such a way that it can perform autonomously based on whatever the user query will be coming in. But even with the AI agents, we have certain challenges. There are like four major like problems which organizations are facing. We have very limited control and customization in like off-the-shelf solutions. We have very long timelines when moving from prototype to production. We have sort of like we face difficulties also like while building for like maintaining those solutions or modularizing those solutions so that the code or the functionalities can be reused. And even sort of like when we have to implement enterprise-ready requirements like security, compliance, scalability of the solutions, whatever we are trying to build, the organizations are facing challenges over there. And I don't know like how many of you have gone through the recent report by MIT also like 88% or 85% or 95%. I'm not exactly sure about the number, but somewhere I know like above or at least like equivalent to 85%, something around that. The enterprises like GenAI POCs, they're not able to like productionize. Like people are starting with the hype, they're trying to catch up, but because of different challenges and not able to solve the ground problems first, they are sort of like stuck over there. So what are the alternatives, right? Like for the challenges we face with AI agents. So this leads us to first we need to understand like classic build versus buy decision, like when we should go for buying out of the box solutions and when we should go for like building something of our own. And we have different open source packages also like LangChain, Llama Index, which gives us like more control, but they require sort of like significant development effort also, right? And if we have to sort of like build custom solutions, which offer like maximum flexibility, but they will require sort of like most time and expertise. And each of these approach has its own trade-off, right? So with this, like the agent, people started building individual AI agents. Like if you go year or 2 year back, like when they were launched, and after that, like because of all these trade-off, if we go with the enterprise-based ecosystem, for example, Google has built a very comprehensive platform that addresses these challenges of like how we can scale the solutions, how we can build the solutions, or secure the enterprise grade. We can apply the enterprise grade security on whatever agentic AI workflows we are building. And it gives us the flexibility of even custom development so that we can easily uh, make use of these managed services and build our solutions around that. So in this ecosystem, like we have several key components here. Like first one is ADK. How many of you have like are aware of ADK or have used ADK, be it in your like own personal projects or sort of like in the company wherever you're working? A lot of you have used it. Awesome, great to see that, right? So ADK is a package which was built by Google team. We can build custom agents. Next tool in the ecosystem is agent-to-agent protocol. So there was an era when people were trying to build individual agents. Now we are like, we need a pool of agents which need to interact with one another also at times. And to standardize that process, like how agents are going to communicate with one another, Google came up with like another like package or protocol, you can say agent to agent, which is used for like if we have to sort of like make two agents communicate with one another, this protocol can be used. Then we have Agent Engine, which is used for deployment and management. We have even Google Agent Space, which is for like collaborative AI experience. And we have a marketplace also of AI agent, like where you will see sort of like pre-built agents and all if you want to use some of the existing agents. And of course, like behind all this, agentic AI workflows, whatever we're trying to build, we have Gemini uh, available through the platform. It is exposed through the API key as well and the Studio platform as an underlying model foundation. Apart from Gemini, like if you want to use some other models from the model garden on Vertex AI platform, you will be able to see those other models as well. So before we like dive deep toward the agentic AI, let's first understand the offerings we have so that we know like exactly what all services are available to us and when and where we can make use of different kind of like offerings from the platform, right? So if you talk about the GenAI offering or GenAI platform, uh, sort of like they have been built and customized in such a way that the companies or enterprises can innovate faster and they can build their solutions like at a like production grade as well. So here, if you look at the top layer, you can build your own sort of like GenAI powered agents. The platform includes sort of like Vertex AI, which will have very comprehensive AI solutions, like based on like if you want to enable some search capability or conversational capability, you can make use of it. You can use those services if you want. If you need some orchestration tools, we have that also available. Grounding mechanism uh, for enterprises, especially the data governance, privacy, responsible AI, security compliance are very crucial. I mean, they cannot be overlooked. So all those can also be sort of like managed from the GenAI stack on the Google Cloud platform. So this is like broad ecosystem of the partners and how we can measure the like enterprise readiness. And if we dive a bit more on the Vertex AI platform, so we have like Model Garden from where you can access open source models, task-specific services you can make use of. We have foundational models as well. And foundational models are sort of like accessible through the generative AI studio also, where you can define and design your own prompts. You can play around to see like what output you're getting based on like whatever you're trying to get, uh, whatever you're making the model to answer. And even if you have to fine tune your models, you can fine tune through the code also, and from the generative AI studio also if you want to do it. Then we have ML platform capability also, where you have like Workbench. You can like as we have the Jupyter Notebook, the same way you can perform experiments, you can train the model, you can deploy. So end-to-end like ML ops, if you have to like build such pipelines, you can do that as well on the Vertex AI. So next, we are going to talk about like model garden. So it's like one place where you can sort of like explore the models available to you. You can fine tune them. You can customize like whatever open source models are available to you, and you can access them sort of like through the API also for the task specific solutions. And if we talk about generative AI studio, so it's a like UI-based platform where you can sort of like give your prompts and you can interact with the model of your choice, whatever you will choose. You can tune the model as well. Once you have the prompt and the answer ready, if you want to get the code and all, you can get it from here. You can save the prompts to the gallery. And like if you're using multi-model capability, then like you can have the prompts designed in such a way that it is performing multiple, like for even for the image generation or even just for getting the simple answers. So if we talk about the Gemini ecosystem over here, you can see it is available for consumers through app and web-based applications. Gemini has been integrated across most of the Google products now, like be it Gmail, Docs, Google Apps, and all. Even if you have used Firebase, we have the like capabilities to sort of like generate the whole application integrated with backend and all on that. So it is helping developers in becoming more productive and efficient. You have, if you're building some applications where you just want to use the Gemini model at the backend, so you can use Gemini API and you can play around with that. For business and enterprise, obviously, like we have the workspace, we have Google Cloud, Gemini, and Vertex AI and all. So to try out AI Studio, I'm not going to focus on these aspects. This is just for your awareness. So you can go to aistudio.google.com. You can generate the API keys. You can create test and save prompts. You can play around and see like how does it work. And as a developer, if you want to try it out, like we have different SDKs like available. If you're whether you're coding Python, Node.js, Swift, Java, you can make use of like any of these SDKs to build your applications. And a lot of time, like even if you're not working on like very custom solutions within the company right now, you can just start with some POCs, or you can participate in like hackathons organized by Google or many other like open source, many other companies. So talking a bit about like platform, right? So there have been a lot of like shift and changes Google team has done considering the user experience and all. So you can start with the Vertex AI, and from there you can access the uh, like Gemini model as well, or you can go to the gemini.google.com as well, I think, and from there also you can sort of like start building the applications. And if you want to look at like some of the examples to try out the Gemini model and what kind of use cases people have been working on, so this is the GitHub repository where you can go and you will find a lot of examples and use cases using Gemini, which you can just try by your own, or you can take the idea from there and you can try building something of your own. So let's start with like the important main part of today's session, Agentic AI, right? So we will see in more depth what it is, how it works, and why it's like particularly powerful for complex healthcare workflows. In between, like if you have any questions, feel free to drop that in the chat. And I will try to take up like as and when I will be checking out the chats over here. Okay. So Agentic AI sort of like they represent a fundamental shift, right, from simple prompt-based response, what we had during the initial days, to complex like multiple system workflows, RAGs and all. We have already seen like how, like as you are seeing in this diagram, right, we have agent which can take a prompt, they can utilize customized models and LLMs. They can even leverage fine-tuned models and RAG systems also. They can Just second. Sorry. They can sort of like interact with applications, data stores, tools, and even like we can have human also in the loop, like if we need. And based on that, they can produce multiple type of outputs, including like automated task, service invocations, physical world actions, and all. So coming back over here, so even like if you have to sort of like control robot also for some of the physical actions, you can build and design the workflows which can be executed on that, and you can make a robot perform just based on like using this multi-model LLM capabilities here. So initially, if you remember the robot days, also like people literally used to sit and define the whole set of instructions, but that has also changed in the industry now. So if we talk about how agentic AI works end to end, so you can see like we start with the input, which goes to the LLM model, whatever will whichever model version or model we would have configured. We can have like multiple LLMs working together as well. We'll have a vector database or like based on the problem or solution you're trying to build. You can even have graph databases for knowledge storage. You will have various tools integrated, tools and applications integrated, sort of like if you want to call them external tool or you want to connect them through the APIs or MCPs and all. The agents will be exposed to such tools so that like if needed, they can just call them and get the required information from there. And we'll have a very like whenever we work with agent, right, we need to have a very sophisticated memory systems also to manage both long-term memory and short-term context. And all of this whole end-to-end workflow is orchestrated to create sort of like multi-agent workflow, right? So end-to-end, if you look at, these are smaller components which we take care of while building the agentic AI workflows. There are a lot of like other nuances as well, which we take care of, like security of the AI agents, what kind of informations we are exposing to the agents, are we exposing any critical information which is not meant to be exposed to them? Before exposing any information, if it's needed to be encrypted or masked, how we are handling that, how we are doing session management, how we are caching certain piece of information so that we are not overheating the LLM models, which can like cost a lot for the application development for the end users or for the enterprises. So there are different other nuances also which we take care of. Like this section is not meant for that, so I'm not diving over there. But you should be aware of like when we say about like automated agentic AI workflow, we should not assume that as a magic happening that it will do everything end to end by itself. We should be paying attention to like even smaller granular details also, that so that whatever agentic AI workflow we're building, it's not exposed to any kind of risk, vulnerabilities and all. So moving ahead, like talking a bit about like agentic AI components, like if we divide that into core components, we can see we have agents at the center managing decision making and orchestration. And this interacts with various data sources, including like be it real-time data or data stores. And it can even utilize functions and frameworks so that like if you have to sort of like execute something and all, so the functions you can take care of. And it leverages both sort of like whatever standard models are available, and even you can like fine tune the model and use it, and maintaining the long-term and short-term memory systems over here. So before I move ahead to the like main use case, I will just look at the chat quickly if you have any questions from anyone. Chat has been very helpful. Okay, we have a couple of links. Okay, people are trying to answer. I will maybe look at the end to the sessions, to the questions. So coming back to the main part of like today's session, right? So we are going to explore smarter medical like pre-authorization use case. We will see like how some of the real world challenges we can solve and why for such kind of use cases, agentic AI fits in very well. Because like if we talk about medical pre-authorization, there are a lot of like complex document processing. We have rule-based decision making. We have to like we need integration with multiple systems, and obviously the need for accuracy is there, and compliance is very much important in the healthcare industry. We cannot expose any of the like critical information, which is sort of like not uh, meant to be exposed out there in the world. So before even deploying these kind of like automated agentic AI workflows, make sure that all the compliances have been met, and you have sort of like gone through all level of security checks and all within your organization and like external organizations as well to make sure that it's not exposing any of the information, so it's not like acting in such a way that can cause issue for production grade solutions. So this is just a sample to understand like how it actually works in real time. But there'll be a lot of like challenges when you'll be actually trying to productionize it. So let's talk about like what are the challenges we faced in medical pre-authorization, right? So medical pre-authorization, if we talk about like any people, especially in US, Europe, and all, people have a health plan so that they can like whenever there is a medical emergency and all, they can go through their insurance providers. And whenever like they consult the doctor, they go through some emergency, the diagnostic report and the other details from the hospital, it gets submitted for approval along with the like insurance number and copy, whatever they have, right? So the purpose of it is like we can ensure medical necessity of the treatments. The healthcare cost can be like managed. Unnecessary procedures, whatever people perform on the day-to-day basis in these kind of like administrative tasks can be prevented, and insurance coverage can be verified before the services also. So there are like nearly 40 prior authorizations like per physician per week. That's the stats like coming from different sources. At a clinic level, like it happens. And if you look at the journey of like prior authorization process, it starts with medication prescription, verification, notification, submission of the like the prescriptions and all. Then it gets accessed by a team, whether whatever prescriptions and diagnosis or reports outcome we have got, it's like and meeting those insurance criterias or not. Then tracking and follow up, then communication, and then like if it doesn't meet, then they have to go for the alternate treatment or appeal for like, no, this is the right, this falls under the insurance claim and I should be approved for it. So these are like some of the steps involved for the medical pre-authorization. And if we talk about some of the current pain points and administrative burden, right, like the amount of people who visit clinics, that volume is very high, and people who are like working in the admin capability as the admin staff, they are very limited in the like hospital. They are there, but like often they get overloaded with sort of like a lot of requests coming in and a lot of things goes in backlogs. And with change in the industry and whatever advancement is happening, there are a lot of like changes are happening in terms of like insurance requirement as well, which makes the life of admin even more difficult to stay current and like with whatever is getting, whatever new instructions are coming from those insurance providers side. And there's a lack of transparency also in the industry, like unclear requirements we often see. So often they get into like what decisions should be making in that process, which often leads to like a lot of confusion and increased denial rates. So a lot of time, the patient who for whom the insurance would have been approved, it doesn't get approved, and there are a lot of like tedious manual tasks which consumes the time of these admin staff, like making phone calls, faxes, scanning the documents, uploading here and there, making the report of filling in the required information like manually. which and when these kind of things are happening manually, there are chances of like human errors as well, which can happen in between, right? So these are like some of the current pain points and sort of like administrative burden. So that's where agentic AI can fit in the healthcare. We can transform the whole. A lot of like companies have already emerged. Like this is not something very new I'm talking about. You'll find a lot of startups. You will just search for it. But this is the unique positioning for agentic AI, right? So that all these administrative process can be sort of automated while maintaining the contextual understanding. We can streamline administrative workflows like pre-authorization, claim processing, extract and analyze information from medical records, providing real-time assistance to healthcare providers, analyzing the patterns to improve efficiency and outcomes. So these are some of the workflows where agentic AI can fit in. What we are going to focus on today is more on the administrative workflow, but beyond that, also there are use cases where agentic AI can play a very crucial role. Just one sec. Okay, yeah. Um, so let's dive deeper into the medical pre-authorization agent. So we have tried building an automated workflow to streamline the authorization process using Google Cloud Services. So it has three main stages, three main agents. One is the insurance agent, which serves as the primary orchestrator, which is built using the Vertex AI agent builder. We have information extraction agent, which parses the document like reports or even insurance document using the Gemini. And we have a data analyst agent, which analyzes and extract the data to make the decisions. So let's dive a bit more towards the architecture side. So we are going to make use of Cloud Run for serverless deployment and um, cloud storage for document storage. We are going to make use of Agent Engine on Vertex AI, which provides the sort of like foundation for building and deploying intelligent agents. We have Insurance Agent built with ADK, which serves as the main orchestrator. We have like and it will be like the insurance agent will be managing the workflow and delegating the task also to the sub agents like information extractor agent or data analyst agent. And beneath you can see like whatever like information we need or whatever sort of like processing or documents will be generated. We are using cloud storage to explore that. So how this workflows work is like we are start with requesting the initiation. Uh, we will upload the required documents. So it will ask initially for the report, diagnostic report, and the insurance document. Based on that, it will extract the information from those documents. It will analyze the information extracted, and it will generate the final report for us. So if you understand the whole workflow manually, right, like how it goes, like if real admin staff sitting at a clinic or hospital, they are trying to do it. So physicians will order a lab test. Okay, then it will be manually entered into the system. Then the verification and eligibility checks are done manually for clearing the uh, clearinghouse or peer portal for that. Then we'll check for the requirements like whatever health plans they have. Different health plans are having different rules, right? And they're complex and constantly changing. So at that instance of time, we'll try to check whether those requirements have been met and checked or not. Then it will trigger the manual work to contact the health plan, retrieve plan a specific form, and it takes. I mean, the time span has shortened to a bit. Like it doesn't take exactly 30 minutes, but I remember like a couple of months back itself, like when I went to a clinic here in US itself, around I think 15 to 20 minutes almost I had to wait after giving my insurance number and all to make sure that like from the admin staff, like before they confirm to me whether like my that test is going to be covered by medical plan or not. And then sort of like it gets submitted through the like system or the phone call, whatever the procedure that insurance provider has established. Then after that, the lab staff continues to monitor the status. If approved claim is billed, then after period, like whatever the adjustment is, whatever insurance is paying beyond that, whatever is left, the sort of like the patient has to pay the remaining, right? So that's the like whole workflow of like how it works. But if we start using sort of like AI agents, so this data is based on it's gathered based on different sources and all different studies. It's like it's not representing the actual industry data, I will say. This is based on the studies and all people have done at different capacity level. But based on the industry, based on those studies, we have observed that we are seeing improvement in reduction in processing time from days to minutes, which can enable sort of like faster treatment approvals. Accuracy has also increased because the human errors are getting minimized. We are seeing the cost reduction uh, in terms of labor cost because we are able to automate most of the processes over here. And also, like it frees up the time for clinical staff, right? So that they can focus on other things. And these solutions can easily scale. So if you look at this graph over here, like impact of agentic AI on pre-authorization process, how much time the traditional processes can take, and with respect to that time, how much sort of like improvement we are able to do across different KPIs, like be it for the processing cost, administrative cost, staff time we are able to save, error rate has been reduced, patient satisfaction is going up. So these all were the theoretical part. Next, let's dive to the coding aspects of it. Okay. So I mean, this use case you will already find mostly online, so you don't have to worry about the code repository and all. I will first explain you how the whole agents and code base has been structured. So let me copy some of the commands over here. And this is the terminal. Perfect. Okay, so Google has provided the whole repository of ADK samples. One of the like examples from that sample repository we are using today for like going through all this. So if you go to sort of like, let me show you this repository actually directly. If you go to github.com/google/adk-samples and this Python one, I mean, you will find the samples in Java as well. So in this repository, you will find a lot of examples and like agents for different purposes, like auto insurance agent, blog writer agent, plant search optimization, and all. And it's very like well documented, easy to follow tutorial. For example, even if you want to, like if some of you are working as a data engineer and you want to see like how I can use data engineer in how we can use AI agents in my data engineering pipelines, you can sort of follow these instructions. What all agents have been developed and build and integrate with your use cases. Like that, you'll find a lot of examples over here. The example which we are going to follow today is like medical pre-authorization. If you will come to readme.md over here, uh, the detailed README file, the documentation and code you can just get from here. I will walk you through the this folder structure specifically, not just the whole repository, and how it works. So we have a deployment folder where we have the files or the code base to deploy that on Google Cloud using the Cloud Run and Vertex AI agent. Services over here. So if you go through like a lot of I mean, some of the configurations we have to provide so that we know which project, in which project we are going to deploy our solution, at which location, uh, in which bucket we are going to store our artifacts or the reports generated and all. And these are like some of the like requirements so that we don't run into package versioning conflict issues, and listing the agents and all. Like these are some of the like functionalities have been defined over here. If you have to test the deployment, we have a test script as well. We will run the test also to make sure that whatever agents we are deploying, whether it's passing those tests or not. We have an evaluation method as well. So whatever agents we have built, this is the function which will call the evaluate. We can evaluate the agents, whatever we're building. We have those capabilities. Once I will spin up the UI of ADK, you will be able to see like how the agent evaluation work or testing work. So this is the function defined for that, for the evaluation of the agent. And for evaluation, we have the test data explored over here, the pre-authorization test and test configuration file of it. Okay, so based on that, it will suggest like when we will actually run the test, it will identify whether our test has passed or not. And this is the actual code where you will find the like sub agents and the main orchestrator agent. So you can see this is the root agent we have defined. The name is like whatever instructions and all you want to give, you can provide the agent tool. Like so, whenever an orchestration agent you define, if you have to connect that agent with different tools, if you have to provide sub agents so that it can work end to end, you within the tools you can either define the agent tool. If you have to give some other tools other than the agents like MCP or something else, those also you can sort of like define over here with different module. And if you go to the information extractor agent over here, you can see this is the information extractor. Beneath, you can see we are using Gemini 2.5 Flash. If you're building some custom solutions on your for your project, you can replace the if you want, if the need is to use the fine-tune model, you can replace Gemini 2.5 with the fine-tune model. Or if you have to use Pro and all, you can just play around with the modeling, whatever you want to use. Then, like you can see, this tool has been exposed to extract treatment name, extract policy information, and extract medical details. So these are the functions to which these are the functions which we have created as a tool. In the tools folder, if you'll go, you will find in this file where you will see each of these functions are responsible for individual tasks. So whenever the information extractor agent will be executing, it will call these functions to get the required information from the document we have uploaded. So this is like overall end-to-end workflow. The similar way, like we still have 9 minutes, I will try to cover up soon. So this is the information extractor tool. The same way we have data analyst tool as well, like in which we have defined the tool, its description and everything. And you can see the tool exposed to this is like a stored PDF. If you'll go to this tool for data analyst agent, you will see we have a function defined store PDF, which generates the PDF of the report and it saves that to the storage bucket over here. And prompt, whatever we are using for this agent, like we have kept the prompt in a sort of like a separate file over here. So you can see like sample report, how it should look like. So that has been given with some instructions and all. So data analyst instruction. So all these prompts have been kept separate. It's a best practice to keep the prompt separate, tool separate, and your agent code separate so that your code is modularized enough. If you have to change anything, you can easily go and just make the changes at that location rather than like debugging around across the whole code base. Similarly, we have a separate prompt for the orchestration agent as well, which is like the insurance agent in our case. Uh, yeah, so this is the folder structure and you will see the UV lock, and also UV is a package manager, which is very fast, like in comparison to Poetry and pip installation. So we are using UV here. .env example file is there. So whenever you will start testing it, you have to make sure that you create a copy of it and name that to as .env and populate all these variables. Okay, so coming back to this code base over here, I will change to the repository agent cd document agentic AI. And let me see in which directory my, okay, cd adk samples, cd Python, and sorry, And let me see the use cases. Yeah, CD agents. And then, so I'm just navigating to the same directory because each of these projects have their individual environment where you can run. So once we are in this repository, let me show you like my env variable, cat.env. Okay, you can see all these variables, whatever is needed, I have already populated over here. Uh, so similarly, like you have to run this command, like if you don't have .env from the CMD also you can run, or if you're using some ID, you can make use of the like VS Code ID or PyCharm or whatever ID like you is your preferred one. Just type .vi.env. Since CLI, this is the command. This will open this file in the edit mode. You can press I and you can like insert like wherever you want. Once you're done, you can save it. So once your environment has been set, you have to set certain like environment variables from the like terminal as well. If you go back to this file, you will see over here, we have to export these variables in the CLI. After these variables have been exported in the CLI also, you have to authenticate your Google Cloud account because from your local system, you're going to connect with the Google Cloud platform to access some of the services. So once you have set, I have already done, so I'm not repeating this step to save some time, but make sure that you follow this step. Next, we are going to start a web interface. So there are two ways of doing that. One is like you can just run UV run, ADK run, and just start the like bring up agents locally, interact with them, or you can run this also, which will start a web server like on our machine. So this is more of like CLI based interaction, and this will give you the UI. So we are going to check it through the UI here. So once we start this, the ADK server will start at our local host. So we'll just copy this URL. We'll go back over here. In a new tab, we will open the like platform over here. You can see we can select the agent. So we are going to select, we have different agents. You can see deployment, eval, medical pre-authorization, test and all. What we are going to use is medical pre-authorization. This is the main insurance agent. And on this, if you have to interact with you can just start typing over here. Let's say if you ask, hello, may I know how you can help me? So you can see it will start processing this information in the background, like we're using Gemini 2.5 Flash model. So based on that, like whatever prompts and the way we have designed the agent, it will start giving us the response. So you can see here it is replying with, I'm a medical pre-authorization agent. I can help you with processing a pre-authorization request. And for that, it needs some information. You can see, right, two documents, medical records and health insurance policy. So once it will have these, it will start with verifying the eligibility and coverage. So how can I help you today? So let's say um, process my pre-authorization request. So now it will ask me like for the files, the name of the treatment you are seeking pre-authorization for, your medical records and health insurance policy and all. So let's start with, sorry, there are a lot of files in my folder, just ignore those. Let's start with like giving them the test files from the sample data. We have, first we'll provide the insurance policy to it. So once it, right now I've just sent the one file to it, right? So it will again ask like, you have just given me sort of like one file, the other two more informations which are missing. So automatically you can see it is like identifying what is missing, what is available. So let's say I will say cataract surgery. I'm seeking treatment for cataract surgery. And then it will ask for like medical record. Since I already have uploaded the insurance policy, so you can see it has maintained that context with it. So next I'm going to upload the diagnosis report. And based on that diagnosis report, it will invoke different agents like information extractor first to extract the information from these two files, process it, and the data analyst agent will sort of like try to analyze whether based on this report and my insurance policy, I'm eligible for the claim or not under my like policy. So you can see this is performing. You can see like whatever invocations have happened through this UI. Events we can monitor from here, like whatever events are we are going through. So for each of the events, you can see which root agent has invoked which. So this is the current event. You can see it has invoked information extractor and data analyst agent. What prompt has been passed in and what is happening beneath. It's still running, so it will take some time. So if you go to the next event, okay, let me show you over here. So different agents, you can see, right, has been, so in one of the events, if you see, we invoked, it was where it replied. Yeah, it was the last invocation when this has been started invocating. This process has started running. Same way you can see, right, like when I uploaded the file, so like it is taking all the like details and trying to process it. So this is how you sort of like, you can look at the events as well. If you go in more depth, like what all request has been made, what for that request, what response we got, all everything can be monitored. So during the development phase, this will help you a lot in sort of like from the UI, you can navigate and identify what is happening in which prompt, what kind of information is exposing, how the prompts are getting regenerated or redesigned, all those things. State, you can see phrase, state and artifacts have not mentioned, so it's not showing over here. So yeah, sessions, like since this is just one session we have started, so you will see your session ID also. So when you will be deploying this as a production grade solution, these sessions will help you sort of like authenticate and track the individual user's request and all as well, and like handle the information in a better way. So that's not like how it is working. Let's go to the like sorry, I came. So this is the report which has been generated by the analyst agent. You can see the request report when it has been generated, then for whom it has been generated, uh, the status of it rejected, treatment plan, insurance provider not specified in the provided details, summary of medical records, summary of insurance coverage, and why it has been rejected. It is coming up with that reasoning as well that it falls within the 24-month waiting period for treatments for pre-age related, and this policy has been like waiting period commenced on 1st July 2024. So that and the request has been made on 19th July, because of which this has been rejected. So he will be eligible for the cataract surgery after 1st July 2026. So such kind of like, this is very simple report which has been generated, but you can modify your agent event to generate, like if you're working with some data analysis problem and all, you can modify and customize your prompts to generate visualization code and even like integrate beautiful visualizations also in your report to make it like more realistic, and you can automate a lot of like manual task of report generation and all. And even you can like configure the next phase of it can be sort of like automatically sending those reports to the corresponding stakeholders or to the patient from here, right? To the patient and insurance provider, like where we have to like send it, or even if you want to capture it instead of like Google Cloud Storage, if you want to capture to a like specific system, you can expose that also to upload that as a file to that system under that patient ID. So all this you can see, right, like with the help of the whole agentic AI ecosystem, how well sort of like the whole process, which can take like 15, 20 minutes, 30 minutes for a admin to go through, understand, and then approve it and make or connect with different people also if they're not actually clear with what they have to do. The agents can perform all this task like in a few seconds or minutes. So this is the example agent which is already given. Like if you are going to try by your own, you can start with this and then can play around. I was talking about running tests and all. So let me open a new terminal over here. This is the last part. Deployment is there. I will see how long we can go. CD documents, agentic, ADK samples, Python, agents, and then. Okay, so next I'm going to run the test and eval. So once we will run this, you will be able to see that the test report as well, whether it is failing or pass. You can see our test cases are failing right now because of whatever so reason. I need to check what has happened. Module not found. There is no module named medical pre-authorization. Why? We are running from the. Okay, it is failing because like I I may need to stop this ADK and run from the same because the environment in this terminal, the environment building is like there's that environment is not like built. UV run will sort of like is building that environment and running it as a like this that repository as a package. So that's why it's missing over there. So anyway, like when you will run this, let me do one more thing over here. CD. Okay, it will not run from here. So let me stop this first. Control C. And from here, if we run, since the environment has already been built in this terminal, still it's failing. Find and load GCD import. Let me see where it is going wrong. Maybe I didn't export the environment very well actually when I started in the new terminal. It can be because of that asset. Okay, something is happening while running the test case. Like when I ran last, it was working, but I think somewhere I have messed up with my environment. It's not running now, and it always happens when we do the live demo. Something has to mess up. So, but when you will start a scratch, mostly it will run. If it doesn't run, you can just ping me. I will help you out, like in debugging. So this is how like you can run it on local. And for deployment, also we have the deployment script. So what it will do is like when you will run this like command, it will deploy your agent on a Vertex AI agent engine, and it will give you this line like in which project where and what's your engine ID where like your engine has been deployed. So we are quickly going to deploy it. Hope it works. Okay, this whole environment has been messed up. It seems. UV run ATK web. Locally, it is working, but somehow this terminal is not picking some of the environment variables. Anyway, I okay, I know what is going wrong. Let me run this command first. UV version and UV sync. Because the environment was not built, I started directly running the package over here. So we are into medical pre-authorization. Yep. And after that, let me run the web. Experimental. Okay, this is working. I just 1 or 2 more minutes I will take before. Okay, something I've messed with my environment. Leave it. The test cases and the deployment is not working. So anyway, like it's quite straightforward. Like I mean, just last night I made sure that the examples are working, but somehow like during the live demo it's not working. So you just have to sort of like deploy this, and when you will deploy it, will sort of like on the Vertex AI UI, if you'll go over here, let me show you that at least. Control.googlecloud.com, and let's search for Vertex AI engine. And if you go to the agent engine, once you execute the deployment command, your engine will sort of like appear over here. So you can sort of like see what all agents you have deployed, and you can make use of like by invoking it from your UI, from your UI or from your application, like from your application or from your CLI, like however you want it. So those are the rest of the instructions which you can follow. So I will stop over here. I will be open to the questions if any. I've taken already like 10 minutes extra.
Yeah, sure. We literally got tons of questions here, so we can
Oh,
just go ahead and answer every of them. Yeah, let's do that.
name difference may be hyphen underscores. Okay, can you help me in moderating the questions, Siddhi, if possible? I can see there are a lot of questions actually.
Yeah, sure. So, from where do you want me to get started? There are a lot of technical questions I'm not aware
Mhm.
about. So, but I can just let you know the names. So we can start with from the Hector Rivera. He did ask you about the different models.
Actually, 1131, right? Yeah, got it.
Yeah.
So yeah, model changes from time to time, add new capabilities. LLM is the general topic. Agents are created using LLMs and are built using the model of LLM that best suits your need. Yes, you're right, Hector. Model capabilities are enhancing, and every now and then we are seeing um, like new version of the models are coming, and that is to make our application and results more smarter, right? So, like it's always like if a new version is coming up, people try to first experiment around the new models to see like how is it fitting in. And there are certain challenges. Maybe the prompt which I've designed with the older model may not work exactly how it was meant to work earlier. So there will be some development efforts or experimentation effort needed, but people try to switch like to the new model if you want to, and it's like again org level strategy and decision which when they decide to switch from one model to another. And even for like switching the models, there are sort of like challenges which we need to be aware of that the same code which is working with the previous version may not work exactly the same. So it always better like if you are going to make such switches for production grade solution, first make that in the staging environment to make sure that your application is working as expected. There are no loopholes. And once you have tested it end to end, then go for making those changes in the production. But like keep track of like what is happening recently and people play around with different models. I hope that answers your question. Next question we have from is the industry moving away from vector DP and in favor of graph DP? Ban it depends upon like what kind of use case we are working on. Uh, I mean, obviously we have a lot of like added advantage of using graph DP. It is able to sort of like go deeper and find more contextual information in comparison to the like structured DB, like where we in this case we have the vector DB for our system. So it depends upon like what kind of use cases you're working on and like how your information is and how you want to structure and store it. And based on that, like people are adapting either vector DB or graph DB or both. Like some of the data they are storing it in graph database, but graph database has its own complexity. Like it's difficult to create. You have to define all the nodes and relationships. So it depends like what people like exactly want to build and what is their application requirement. Next question we have is from what is the difference between models and LLMs? Models we can refer to like machine learning model, or we have anything which whatever you have trained on any data that is a model basically, right? So often you will see the exchange of terms. Sometimes we'll call model, sometimes we'll call multi-model, sometimes we'll just call LLMs. LLMs are like just large language models. Gemini and all are like multi-models, which has the like capability of like not just handling text based generate giving the response in just text based. If we want to generate like images and all such kind of like capabilities, if they have like of audio, video, speech and all, those are considered as multi-models, which has these capabilities. So that's the difference. So even traditional machine learning model also, if you have trained on some data, that will be also called as model. If that's answer your question, Namdi. Next, we have a question from Kat. How is data included in the prompt? So we define the system, we design the system in such a way, Kat, that the data is exposed, if the data is stored in a bucket or in a database, or if it is accessible through an API, we define a function for that to establish the connection with that source. And sometimes like we have predefined queries or instructions, how we want the data to be pulled out or to be pulled from that sources. Or sometimes we have to dynamically generate the uh, data we want. So the query will be like automatically generated. For example, if you are trying to fetch certain data from a SQL database, then based on like whatever user query is, whatever user requirement is, the LLM will parse all those informations. It will identify the column names using the metadata and the information it will be having of that table. And based on that, it will generate the query dynamically and will fetch the data from that data source. There are different ways of like configuring those tools. And real-time data stored can be like accessed through API or MCP servers. A lot of like tools are getting exposed through the MCP servers. Size limit, yes, it has. Like if you're going to load GBs or petabytes of data for a small application which is not needed. I mean, for processing and all, like you might need certain MBs of data, but we have to design the prompts to fetch data dynamically in such a way that those wherever we need to optimize the solution, those are optimized, and we are not going very wrong in terms of like designing such systems.